Welcome to today's lesson. Today we're going to be solving trigonometric equations. Now we're going to talk about trigonometric equations. There's two methods to solving trigonometric equations. Method one is to use a unit circle as a visual aid, and method two is to use the graph of a function as a visual aid. Let's take a look at method one first. In our first method here, we will use circles, unit circles, to help us solve trig equations. Method 1, we're going to use the unit circle. Please don't forget this triangle. 30, 60, 90 goes across from 30 is 1/2, across from 60 is square root of 3 over 2, and across from our hypotenuse is 1. It's because it's part of the unit circle. There is your radius. Sine theta equals 1/2. We're asking, where does the sine theta equal 1/2? Well, don't forget, sine is associated with y. If we're associating cosine with x, sine is y. Well, on my unit circle, remember I have the point over 1, up 0, and here's the point over 0, up 1. At this point, my y equals 1. So it goes to figure, for me, logically, that halfway between 0 and 1 on the y-axis, sine is going to equal 1/2. So I drew a line here, this dotted line, at 1/2. Well, when does my theta meet that line? Well, right here. When is the sine 1/2? Well, here, this distance here is going to be 1/2. This distance here is 1/2, and I can use my triangles. If that's 1/2, that's 30 degrees, or pi over 6. Pi is 180 divided by 6 is 30 degrees. Well, if I keep on expanding my theta out, again, right here is where I'm going to meet this line again. Here, again, my sine is equal to 1/2. Opposite this angle is equal to 1/2. But here is my theta. From this horizontal line, I'm opening up the angle, and that is my theta. What is that theta equal to? It's equal to pi, which is 180 degrees, minus this angle here, which is pi over 6. So theta is equal to pi over 6 here, and then pi minus pi over 6. I back it up a little bit. So far we have theta equals pi over 6, and then 5 pi over 6, which would be pi minus pi over 6. We continue on with this example by opening our theta. We saw it hit here and then here. We continue opening the angle all the way up to one complete circle, which is 2 pi, and then we add another pi over 6 because this is still 1/2 here. If that's 1/2, I use my triangle and I know that angle is 30 degrees or pi over 6. So what is this angle that goes all the way around the circle once and then an additional pi over 6? It's going to be 2 pi, which represents one rotation around the circle, plus 30 more degrees, or plus pi over 6 more. Here, I'm going to go all the way around the circle, all the way up to 2 pi plus pi over 6, plus some more, because here, again, I have my sine, or my y, equal to 1/2, and there is pi over 6 in there again. Well, I went pi, 2 pi, all the way out to 3 pi with this. 3 pi minus pi over 6. If I have 3 pi minus pi over 6, those are our third and fourth values. It would be 2 pi plus pi over 6, and then 3 pi minus pi over 6. Continuing on with this basic trig equation, sine theta equals 1/2. Instead of going in the counterclockwise direction, we could go in the clockwise direction. Many of you know you have to say that the angles are negative in that direction. Well, again, this angle here is 30 degrees, or pi over 6, for reasons we discussed before. If I'm going this way, I'm going to have negative pi, or negative 180 degrees, minus 30 degrees, or minus pi over 6. So I start negative pi to there, and then I have to subtract more pi over 6. Here, when I reach there, going the clockwise direction, which is the negative direction, I could consider going all the way over to negative 2 pi, and then going back pi over 6. That would be negative 2 pi plus, back it up, pi over 6. I hope that you can see if we went all the way around and then came back to here, that we'd be talking about a theta of 1, 2 pi, 3 pi. So it would be negative 3 pi minus a little more, minus pi over 6 more. We just solved this easy trig equation, sine theta equals 1/2 using the visual aid of a unit circle. And we found it was pi over 6, pi minus 1/6 pi, which is 5 pi over 6, 2 pi plus pi over 6, which was, if you work this out, that's 13 over 6 pi. We found that in our opposite direction. We did negative pi minus pi over 6, and then negative 2 pi plus pi over 6. That's the results we found before. Well, how can we use the graph of sine to help us do that as well? Here I've drawn sine from negative 2 pi to a little more than positive 2 pi. That gives us one cycle and then 2 complete cycles. Well, where does sine theta equal 1/2? Remember, sine theta equals 1 up here. If you remember your unit circle, that's going to be pi over 2 and negative 3 pi over 2, and also it's going to equal negative 1 at 3 pi over 2. Where does sine theta equal 1/2? Well, here's our line 1/2. And we want to know all of these values. These values are going to continue to repeat for as many cycles of the sine curve that we draw. It's a periodic curve, so theoretically it would go on forever in both directions. We'd have infinite answers here. Well, they'll limit the domain so that you can only get a certain amount of answers. If they said from negative 2 pi to 2 pi, we'd have 1, 2, 3, 4 answers or solutions to this problem. Well, let's take a look at this. Where does sine theta equal 1/2? You could solve this on your calculator, provided that you're in radians. Where does sine theta equal 1/2? Take arc sine, or the inverse sine of both sides, and you get theta is equal to sine inverse of 1/2. If you put your calculator in radians, you'll find that that is equal to 0.524, which is equal also to pi over 6. So here is our, where does theta equal 1/2? At pi over 6, or 0.524. That's in radians. Well, because our graph is cyclic, that's going to repeat every 2 pi, because we're dealing with the parent function sine theta. So every 2 pi, that's going to be repeated. So if I add 524 plus 2 pi, which is 6.18, I will get here, which is 6.81, which is a little more than 2 pi. Why does that make sense? Because we know that 2 pi is equal to 6.18, which is 3.14 times 2, or 6.28, not 6.18. 6.28 is 2 pi. We also found here that one of our answers was pi minus pi over 6, which was 5 pi over 6. We see that here. If I have pi and I minus pi over 6, I'm going to get this, which is 5 pi over 6, or in radians, it's 2.62 radians. So the two graphs match up, and which you use depends on what you're more comfortable with. In addition to using the unit circle as a visual aid to help us solve trigonometric equations, we can also use the graph of the trig equation. Here I have sine theta from negative 2 pi, there's one cycle, over to 2 pi. Well, a little more than 2 pi. So I've drawn a little more than 2 cycles of this, because we know one cycle of the parent function is 2 pi. Well, where does sine theta equal 1/2? I know sine theta equals 1 up here. 1/2 would be halfway between my highest point and my x-axis. So I draw a horizontal line at 1/2. Now, I've only limited my domain to negative 2 pi to 2 pi, but you could continue, theoretically, in both directions forever, giving us infinite solutions to this equation. I want to know the angle of theta that will give me 1/2 here. I'm looking for the angle. Here are 1, 2, 3, 4 solutions between negative 2 pi and 2 pi. Well, how do I do this? I need my reference angle here, one solution. Probably the first solution you come to you can call the reference solution. How do I find that? Sine theta equals 1/2. I can take arc sine of both sides. I get theta equals the inverse of the arc sine of 1/2. Well, when I do that on my calculator, when my calculator is in radians, I'll get pi over 6. Or maybe I'll get, it depends on how your calculator is set up, you may get something like this, 0.524, which is pi over 6. To me that makes sense because I know pi is 3.14. Here, it looks to be reasonable, that is about 0.5. Well, because my period in a sine function, the parent function, is 2 pi, I can add 2 pi. Well, 2 pi is 2 times 3.14, or plus 6.28. When I add 6.28 to that, I get a total of 6.81 radians. Well, if I have a solution here and I go over 2 pi, I'm going to find this solution here, which happens to be 2 pi plus pi over 6. And in radians, that's what that is. Well, I found this solution here, and I also just found this one. That's the 13 over 6 pi, or the 2 pi plus pi over 6. There's a periodic nature, so every time I'm on the upswing of this curve and it hits my line y equals 1/2, it's going to happen again, but a distance of 2 pi later. It depends on what your period is. The period here happens to be 2 pi. That's why I'll hit it at that point later. Also, I saw when I did it with the unit circle, I saw it was pi minus pi over 6. That's how we got this 5 pi over 6. Well, if I do pi, which is 3.14, minus pi over 6, which we found was 0.524, 0.524, when I do that, I get 2.62. That's how many radians I have to go. There is 2.62, and that gives me my other solution there. I could certainly do the same thing in the negative direction, finding negative pi minus pi over 6, and then again going 2 pi that way to find another solution. If I found this solution and this solution, I just keep on adding 2 pi, or subtracting 2 pi to find my additional solutions.